No?
Just about kinetic energy. That's all.
Did I not tell you that this is the nucleus? Then
Yes, sir. Yes, sir.
yeah, right. Okay, fine. So I have told you that, and the Bohr model, there are those orbitals, those orbits that we have, that we called as K, L, M, N. Now these K, L, M, N are also known as 1, 2, 3. We will write this thing, but these are what? These are also representing energy levels, and the energy can only be found in discrete states that we saw in the Planck's quantum theory, right? So if you see the Planck's quantum theory, what did he say? The energy is in the form of, these are packets of energy, right? It is in packet and it is quantized. Quantized means what? It will be a whole number. It can be either a particular number or next particular number. It cannot be in something which is continuous like 1.5. Okay. So the same idea, I mean, he based the model, the Bohr atomic model is based on the idea of quantum theory. Okay. So Bohr's model of atom, please write the heading. Bohr's model of atom. Okay. So please write this thing with me. I mean, most of the points that you will be writing here are the points from your lower classes. Okay. The first point, the electron is revolving a circular path around the nucleus. It is called orbit or shell or energy level. So orbit or shell, you knew it, right? From the 10th standard also, 9th standard also, you knew that it is orbit or we call it shell. Now energy level is a new term. Energy level is a new term. So the first statement of Bohr model of atom is electron is revolving please write this with me, okay? In circular path around the nucleus. Okay, so it's circular path around the nucleus. And what are these paths called? It is called, what are these paths called? Somebody please tell me. Orbit, na? Or shell or energy level. Yes, Hamza, Khalid and Salman, Hiba. I hope you knew this line, right? About Bohr model?
Yes, sir.
Yeah,
Yes,
okay.
sir.
Thank you. Okay,
Yes,
fine.
sir.
I was like, I'm telling you this for the first time. Okay. Now, see, if an electron is present in a particular level, I mean, we have discussed this idea in the yesterday's class. This is one energy level. Okay. Let us say this is the first shell. Okay. This is the first shell. And the electron is in this particular orbit. Okay. Now, what will happen when it is revolving around, then it can neither radiate any energy. I mean, when it is revolving around the nucleus like this. So when this electron is revolving around the nucleus, it cannot emit and it cannot even absorb any energy. As soon as it will emit some energy, it will fall down towards a lower level. Because when it emits energy, what will happen? Its energy will decrease and it will get into some lower level of energy. Now, what will happen if it absorbs energy? Now, if it wants to be in the first orbit, what it should do, it should have a particular constant energy. Now, as soon as it absorbs some energy, what will happen? It will shift towards some higher energy level. Okay, this is the second point of Bohr model. Second point of Bohr model. So let us write this in word. Did everyone understand this point?
Yes, sir.
Okay, if electron is present in particular orbit, then it can neither radiate or emit nor absorb energy. Okay, what does that mean? That means that the energy of a particular level, a particular orbit or a particular shell is fixed. This means that so the energy of every orbit is fixed. Every orbit is fixed. Okay. Now, what will happen if we if the electron changes its energy? or it changes its orbit. If it changes its orbit, what will happen? It will also change its energy level. So that is the third point. Energy of electron changes if it goes from one orbit to other. It goes from one orbit to other. Okay. Now, what will happen when the transition of any electron, it will take place from one orbit to other. So we will have E2. Okay. This is the first, this is the final energy level minus E1. Okay. So what we are calculating here, the change in the energy of electron. So the change in energy of electron, we can calculate. If it is in the first level, the energy of first level will be something, and it went to the second level. So the energy of second level will be something. That is E2 minus E1. And when we see E2 minus E1, this will be equal to what? H nu, because this is also an energy. And this frequency is the frequency that should be applied to the electron to get it from the energy level 1 to the energy level 2. Okay. So this is a formula. If somebody is asking you, how much frequency will you need to shift an electron or to bounce an electron from the first orbit to the second orbit, then you will say, you will ask what is the energy of the first orbit, what is the energy of the second orbit, and then you will apply this formula to calculate the frequency needed for the transition. Did everyone understand this point?
Yes, sir.
Okay, very good. So E2 minus E1 is equal to H nu. So the fourth point is the force of attraction. Are you guys writing with me? Please write with me, okay? Between the force of attraction between the nucleus and the electron. Between nucleus, okay, I need to text now. Nucleus and electron must be balanced by centrifugal force. Okay, do you guys know about centrifugal force now? I don't know about centrifugal force. If you don't know, please say no, sir. Yes, no, somebody please.
No, sir.
No, okay, fine. So see, have you done something experiments, or have you seen someone get a bucket or a mug, and this mug he is carrying on in a particular, okay, even if you take one bucket like this, and this is the handle, you pick up the bucket with your hand and then start revolving your shoulder complete 360 degrees, and there is some water in the bucket. Now if you're revolving it so fast, then you know, right, that this water in the bucket, it will not go out, right? It will never fell down. No, you don't know this.
No, sir. Actually, like water may fall down because, but if it is in a small quantity, like in glass or something, it won't fall.
No, even if you have in bucket, but it depends on how fast you are revolving that. How fast your
Yeah.
shoulders are moving.
Yes, sir.
Okay, or rather, yeah, there is one more thing. Okay, fine. What will happen if you have a stone? You have tied that stone with a rope, and then you are just revolving that rope. Okay. Now tell me, if you are revolving that rope and at a particular time, you don't hold it, you leave the rope. Okay, you are not applying any force in any direction. So what happens when you are revolving? It is revolving, but at this point, you are not holding the rope, you left it. As soon as you leave it, it will not go round and round, it will follow a tangent. Correct?
Yes, sir.
Okay. Now as you can see, that means there is some force which is applied in this direction, right? Inward direction. Correct? Now what was holding that stone? The amount of force, but that you are holding, the strength by which you are holding that rope, it is stopping that stone to go anywhere. So similarly, the Coulombic force is there, which is stopping the electrons from moving anything. So what is, there are two forces which are in action. Okay, there are The first one is the positive charge is attracting the negative charge. Now this type of attraction, what will happen? The electron will start revolving as the earth is revolving around the sun. Okay, as the earth is revolving around the sun, the negative charge, it will start revolving around the positive charge. Now as it is revolving around, it is also getting a force which may make the electron leave the trajectory as the stone left that circular trajectory when you left it. So the force of attraction that is between the Coulombic force, this is the force of attraction, and this force is the centrifugal force. Okay, so what is the Coulombic force? Coulombic force is equal to, we will learn this Coulombic force. Okay, does someone remember the formula for gravitational force? No? Yes? Anyone?
Sir, F is equals to mg.
No, not mg. Okay, fine. You have in 11th standard you have a chapter on physics, gravitation. So it is g m1 m2, but here it is
Yeah, I know that, sir.
right. So it is
Capital G into m1 into m2 by r square.
r square. Yeah. So this I mean Coulombic force is similar. It has a constant that is k. Now rather than mass, it should have what? It should have charges. So q1 q2 you can write q1 q2 are divided by r square. Okay, q1 q2 divided by r square. So for example, if I am writing here for Coulombic force for hydrogen, so in hydrogen we have only one proton and one electron, right? So we can write k into what is the charge in this positive charge is the same charge as much as there is an electron, okay, but it is in positive. So we just take the magnitude here. This also has the charge here, and here it is same, right? The amount of charge present in proton and the amount of charge present in electron, it is same. You guys know this, right?
Yes, sir.
Anna? Okay. So we can write into the charge is equal to the elementary charge E, and then again 1E divided by R square. So I'm writing here E for proton and E for electron. Okay. This is the elementary charge for proton. This is the elementary charge for electron. This is only the magnitude. We don't take the sign here, divided by R square. But what will happen if I say the Coulombic force for helium? This will be equal to K into how many protons will be there in helium? How many protons in helium? What is the atomic number of helium?
1, no, 2.
Atomic number is 2. So how many protons? 2 protons. Now there
2.
is, okay, so EP, then you will have one more EP, right? The complete charge. So plus you will write one more EP, the elementary charge due to proton. This is the complete charge in the proton. Then you will multiply this charge to elementary charge due to electron and divided by R square. So rather what we can do, we can write a formula like this. The Coulombic force for any system, that is the atomic system here, we can say that it is K. Then we can see, right, Z. What is Z? Z is the atomic number. Then we can write the E square divided by R square. Okay, so this is the Coulombic force. This is the Coulombic force. So what is K here? Okay, now since here how many electrons are also there? There are 2 electrons also, right? You can write here electrons. So this is the formula. Okay, so let us erase this thing. And this is Coulombic force. We write this above. You understand now how Z came here? What is Z?
Yes, sir.
Z is
Sir, what
Atomic
Z
number.
again?
atomic number.
Oh, atomic. Okay.
Okay, Z is the atomic number. Okay, Z is the atomic number. So this is the Coulombic force. Okay, Coulombic force. Let me write it all, because again centrifugal force will also be CF. Coulombic force. Now centrifugal force, it is equal to mv square upon r square. Okay, this mv square upon r square. So what we can do here, we can equate these two. So we will write, because these, until and unless these are equal, what will happen? See, please listen. Okay, don't write here. Please don't write here. This is your orbit. This is your orbit. Here is your nucleus. This is your electron. This green part is your electron. Now the force of attraction between the nucleus and the electron is the Coulombic force. So this is keeping it inside the orbit, correct? Yes. Yes, everyone. This
Yes,
Coulombic
sir.
force, it is keeping it. Now there is another force which is centrifugal force. We can represent it like this because as soon as the centrifugal force is applied, the attraction between the nucleus and the electron is completely over. The centrifugal force will be getting applied and the electron will follow this kind of trajectory, that is tangential. Okay. Now I am asking very simple question. What will happen if, so this is one is Coulombic force, okay? One is Coulombic force is greater than 2. This is one Coulombic force and this is 2. What will happen? If the Coulombic force is more than centrifugal force, the force of attraction between the electron and the nucleus is more, the electron will come nearer to the nucleus. Is that right?
Yes, sir.
Okay, what will happen if we have 2 is greater than 1? What will happen? If 2 is
Force
greater
of
than
attraction will be less.
force of attraction will be less, that means it will be getting away from the nucleus, right?
Yes, sir.
Okay, that means centrifugal force is more now. So now what will happen if 1 is equal to 2? If 1 is equal to 2, then that means it will be remaining in this particular orbit, the black orbit, correct?
Yes, sir.
Okay, fine. Thank you. So these are the two forces and we need to equate these two. So we can write K ZE square upon R square is equal to MV square upon R square. MV square upon R square. Okay. Now these are two things. I mean, these should be equal. So we have just stated the same thing here, that we have the force of attraction between the nucleus and electron must be balanced by the centrifugal force, and the numerical terms are here. Okay, did you write this slide, the first slide?
Yes, sir.
You have written it. What about the second, this one till here?
Yes, sir. Written.
Okay. So let's write the next point of Bohr atomic model. Let us keep this here. Okay, you can draw this also. Okay, this 1 and 2. 1 is what? Coulombic force, and the 2 is centrifugal force. Now, do you know about, I mean, you don't know about angular momentum also, right? You know about angular momentum? Momentum? No? Yes? No. I mean, there is some physics which goes on. So you can write this statement, then I will explain it. Okay. Right, out of various orbits of electron, electron can revolve in that circular orbit whose angular momentum is an integral multiple of h upon 2 pi. It is the integral multiple of h upon 2 pi. What is the angular momentum? Angular momentum is m into v into r. Do you know about momentum? Yes, momentum. Do you know about momentum?
Yes, sir.
Momentum, do you know? What is momentum? Formula for momentum? Are?
PV.
What is P?
So P is equals to MV, mass into velocity.
Yes, okay. So see, now I'm telling you a very interesting thing. You will be learning about circular motions, right? In circular motion, what will happen? See, you will get angular velocity, you will get angular momentum, you will get angular kinetic energy. The difference only will be whenever you are having a circular motion, there will be a radius, correct?
Yes,
Right?
sir.
Now, as soon as you multiply that radius to the linear momentum, there is one linear momentum when you have linear motion. You have angular momentum when you have circular motion. So as soon as you add r, that will be the formula for. Now in the physics class you can also tell the formula when Azam sir asks you. Okay, angular momentum, even without studying you will say mvr, because momentum is mv. Just add or multiply r. What will be now? See, omega. This is what? This is velocity. Okay, so you will learn about omega also. Where will you learn omega? Omega you will learn in physics, circular motion. So this is the integral multiple of integral. Now what does, okay fine, I should integral, this spelling is not right. Integral multiple of h upon 2 pi. Integral multiple means is equal to n into h upon 2 pi. N into h upon 2 pi. What is this n? N can be equal to 1 comma 2 comma 3 comma 4 dot 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 dot. Okay, tell me if you have written this. This angular let me know if you have written this. Okay,
Yes, sir, done.
Done, sir.
done. Okay, what about others?
Done, sir.
Salman, done.
Done, sir.
Done. Okay. The next point, how many points have we done? We don't know how many points. Okay, then dot. Bohr's orbit. Those orbit that you call KLMN now are also known as Bohr's orbit. Is also called wait a second. If I write a bit above now, sometimes those control things get down, and also called stationary orbits. Okay, why stationary orbits? Can somebody tell me why stationary orbits? What is stationary? What is constant in the orbits? What is the thing which is constant in the orbit? Yes. Electron is moving, right, guys? Electron is moving, right?
Yes, sir.
Okay. Now tell me.
So nucleus.
No, nucleus is not in orbit, na. So in orbit, what is happening? What is constant in the orbit? What is constant in the orbit? Read the-
Orbit.
Energy.
yes, Hiba, what did you say?
Energy.
Yes, very good. Energy is constant, na. We have written the second point, energy is fixed, correct? So this is known as a stationary orbit because electron is moving in circular orbit of fixed energy. Okay, so this can also come in your assertion reason question type. Okay, so every point is important. This model, okay, now this is the limitation also, but you can write it here. This model is applicable for only one electron system. Okay, one electron system. What is the, what are the example for one electron system? There is one electron in hydrogen in one electron system. Now if I add helium positive, it is also what, one electron system. If I add what, lithium 2 positive, it is also having only one electron. Okay, helium positive, we have removed an electron from helium. Lithium 2 positive, we have removed an electron from, so we have removed 2 electrons from lithium. You can also write sodium, how many positive, how many electrons are there in sodium? How many electrons in sodium? What is the atomic number of sodium? Re.
11.
Very good. So 11 electron, we need only 1 electron. So I have to add plus 10, remove 10 electrons, okay, etc. This model is only applicable for one electron system. Done. Now there are few things that Bohr gave, and it has some mathematical applications right here. So Bohr was also able to calculate the radius of a particular orbit, okay, in which the electrons are moving. Wait a second now. Yeah, sorry. Okay, so write mathematical analysis. Mathematical analysis of Bohr model. छौंक जानते हैं आप? छौंक लगता है, पता है आप लोगों को? डू यू नो व्हाट इज छौंकना? दाल
No,
छौंकी,
sir.
तड़का तड़का तड़का
Oh, yeah. Yes.
तड़का। हाँ, तो कुछ तड़का डाला गया है। Right, radius of orbit. So see, the mathematical derivation is out of the syllabus. We cannot exactly calculate how we cannot derive how he came out with this. The radius of any orbital of n. Okay, what is this n? N is the shell number. It is equal to 0.529 into n square divided by z, and whatever you answer, you will be getting in angstrom. You will be getting in angstrom. Okay, so write also 1 angstrom. This is what angstrom. 1 angstrom, it is equal to 10 to the power minus 10 meters. Okay, so what are the things here? What is n? N is equal to the shell number. What is z? Z is equal to the atomic number or proton number. Okay, so this is the radius of orbit. Write this slide. Write the first point, then we will look at the second point. Are you guys done?
Yes, sir.
Yes, sir.
Khalid, Salman.
Yes, sir.
Now write energy of electron. Second point, radius. Sorry, first point is the radius. Second point, energy of electron. Energy of electron, it is equal to the total energy is the kinetic energy. The electron is revolving. That is why it should have some kinetic energy plus potential energy. Okay, so where does the potential energy comes from? Potential energy is from the Coulombic force. It is from what? It is from the Coulombic force, and kinetic energy by the motion. Kinetic energy is by the motion. Okay, so we have seen one formula where we saw that it is mv square upon r, right? Centrifugal force, sorry, mv square upon r square or r. What did I write? Did I write?
Sir,
MV
R square.
R square.
Wait a second, please change that now. It is mv square by r. Kinetic energy, total energy, mv square. Yeah. Okay. mv square by r. This will be equal to k into z into e square by r square. Okay. So the first thing that we can eliminate is this r by this r. Then what did I do? I added half both the sides, and I added half here also. So now you can see this is what, half mv square, which is equal to k into z into e square divided by r, and this is also half, right? So I can write 2r k ZE square divided by 2R. What is this term? What is this term? Half mv square. What is half mv square? Arre, guys, you have forgot everything. Azam sir will kill you. Azam sir takes your.
Kinetic energy.
This is kinetic energy. Very good. Half mv square, guys. Kinetic energy. Okay. It is what? It is kinetic energy. Okay. Now, for potential energy, you have to remember this formula. Potential energy. It is equal to minus of k ZE square divided by R. Okay. Potential energy, it is equal to k Z E square divided by R. This minus sign just shows that the potential energy is by attraction and not by repulsion. Okay. That potential energy is by attraction. So negative sign, wherever you see negative sign, just think about stability and think about attraction. Now what we can find the total energy also. So this total energy will be equal to kinetic energy. What is the kinetic energy here? Kinetic energy is equal to k into Z into E square divided by 2R plus you have the potential energy. What is the potential energy? It is equal to minus of k into Z into E square divided by R. Now tell me what will be the answer. Which is bigger, the first term or the second term? Which is bigger? I mean, if you don't see the sign, which is bigger, first term or second term?
First term.
First term is bigger. If you don't see the sign, magnitude, I'm asking about magnitude. Can I write the first term as, see, all the things are similar, na? Kz E square upon R, Kz E square upon R, everything is similar. So can I write this first term as 1 by 2 and this term as 1? Everything else will be common, the same.
Yes, sir.
Okay, so what is bigger, half or 1?
1, sir.
1 bigger. So second term is bigger, right? Second term is bigger.
Yes, sir.
Okay, so I'm telling you the answer will be kz E square divided by 2R. Okay, I mean, it is very easy to calculate this. I mean, simplification is there. Just spend a few seconds and tell me if you understand this or not. If you don't understand, then we will do it, no problem. Okay, but in 11th standard, you must know to simplify this fast. So, okay, wait a second. This is very bad too. This is very bad Z. So what I am doing, I will write the Z like this. Okay, with a little dash here. And the 2 like this. Yeah, it is good now. Okay, did you guys understand? Didn't understand. Hamza, Hiba, Salman, Khalid. No one. No one. Okay. You guys have maths, no? Or do you have bio? You guys have maths, no? Right?
So I'm maths.
Hiba is
Hiba, yes.
okay. Kz E square divided by R. I took it common. Then I had 1 by 2 minus 1. Okay. So what did I write? I would write kz E square divided by R. Okay, now tell me half minus 1. What will be the answer? Half minus 1.
Minus half.
Minus half. So this is now equal to minus kz E square divided by 2R. Got it? कितना आसान था बताइए आपको. So easy. This is आसान. This is आसान. Complete the slide. Done?
Yes, sir.
Yes, sir.
Everyone done? No. Okay, fine, done. Now we will write the energy of orbitals. We have calculated the total energy now. So the energy of orbitals, if you have at n orbit, it is equal to minus 13.6 divided by n square into z square. What is n square, Hiba? What is n square, Hiba? What is n? Are Hiba? What is n? Yes, Khalid.
Shell number.
Shell number.
Shell number. Yeah, shell number. Okay. What is z, Hiba? What is z?
Atomic number.
Yeah, atomic number. Okay. So if you I mean, if you write it in this formula, you will get the answer in electron volt per atom. If you use this formula, minus 2.18 into 10 to the power minus 18 divided by n square into z square, you will get the answer in joules per atom. Okay. Now, if you have energy of any orbital will be equal to minus 1312 divided by n square into c square, the answer you will get will be in kilojoule per mole. Okay. So these are different formula for the energy of any orbital. Got it? Write this down first. Write this down. See, all these energies are in negative. All these energies are in negative. That means the most common energy is what the attractive force is present. Okay. So all of these energies are in negative. That is why the electrons are stable in a particular orbit. Guys, done?
What is En? En is energy.
Energy of the nth orbital. Okay, energy of the nth orbital. So if I write, for example, what is the energy of? Okay, let us find it out. Calculate. Calculate the energy of first orbit in electron volt per atom for hydrogen atom. Yes, calculate this. So you write it like this: E1, it is equal to minus 13.6. What is n here, Hiba? What is the n here? What is the value of n?
1.
Very good. What is the value of z? What is the value of z?
1.
Very good. So the answer will be minus 13.6 electron volt per atom. Okay. So this is the energy of the first level. This is the energy of the first level. Okay. Now see, I have done this question. Okay. You guys will do the next question. Okay. Write this down first. Done. Everyone done?
Yes, sir.
All of you?
Yes, sir.
Calculate the energy of the electron present in helium atom, or rather I should say helium positive ion. Okay, helium positive ion. So where will be the electron? In which orbit will be the electron for helium? If I have removed one electron, where will be the electron? In which orbit will be the electron?
In the first orbit.
In the first orbit. So you have got the value of n. What will be the atomic number of helium? What is the atomic number of helium? What is the atomic number of helium?
2.
So 2.
So you have got the n, the orbit. You have also got the atomic number z. Can you calculate in electron volts? Electron volt per atom. Calculate this fast. Tell me the answer, okay, when you're done. Okay. in the chat. Please write the answer in chat. I guess I told you guys, na, I'm in Delhi.
Yes, sir.
Abhi, I mean, before your class, I've reached home just 15 minutes before. I was in Purani Delhi for some things. But basically, I went there for specs. I needed to change my specs. How is correct answer? Very easy calculate. Okay, fine. I won't disturb you with my stories here. Okay, please calculate fast. And I'm hungry right now. अरे no one else is giving answer, I will be sad. एक तो इतना थके हुए हैं. It is just similar. You have to just change the z. It is just like previous question. Hamza, Hiba, what? Are you stuck? Are you stuck?
No, sir. By mistake, I forgot. I sent to the host.
Okay, but you have sent it to me now.
Yes, no. Again, I sent it to you.
So did you put the z? What is the z?
2,
So what will the 2 square?
4.
So why didn't you multiply that then, guy? Yeah, 1 square. That is why we didn't multiply it now. 1 square is 1 only. Yes, Hamza.
Yes, sir. Yes, sir.
Got it. So the energy will be equal to what? It will be equal to 13.6 into z square divided by n square. This will be in electron volts per atom. Okay, this is in minus now. Then yeah, this will be in minus. So this will be equal to what? Minus 13.6 into 2 square. This 1 square, n square is equal to 1 square. So I can write it again as minus 13.6 into 4. This is 1 electron volts per atom. This will be equal to 54.4 electron volts per atom.
Sir, minus.
Yeah, right, minus. The minus shows what? Attraction. Minus shows attraction. Okay, now I'm asking, suppose I want to remove the electron from, let us say, start with the hydrogen atom, simplest atom. This is a nucleus. We have this orbit in which the electron is moving. Okay, now we know the force of attraction, right, between the electron and the nucleus. Correct, guys? We know the force of attraction. It is equal to how much? 13.6 electron volt. I mean, this is 13.6 electron volts is stopping the electron to move on. So how much energy should I give this electron to get it away from the influence of nucleus? How much energy should I give it? Just imagine something like this, that there are two persons, they are holding each other. Okay, they are holding their hands, and the force of attraction between those hands, the strength of those that holding is what? 13.6 electron volts. So how much energy will you want so that you can break that particular bond or break that particular hold, the force of attraction between those two people? Think in that way. How much energy will you put?
Sir, I guess double of it.
Double. What will happen if I put the same energy? Then also they will, that bond attraction will break now, right? Then also
Yes,
the attraction will break. Okay, so a new concept comes here. It is known as ionization energy. It is known as what? It is known as ionization energy. Ionization energy. What is ionization energy? I mean, it has a very radical kind of definition. Okay, so it says that the amount of energy. Please write it with me. The amount of energy required to remove the electron from ground state to infinite. बच्चे जब इनफाइनाइट सुनते हैं तो उनको लगता है मतलब it would need infinite amount of energy, sir. If we want to send it to infinite from the ground state, that is the most stable state. For example, for hydrogen, the ground state of hydrogen is what? The ground state of hydrogen is the first orbit. What is the first excited state? If I get it excited, it will be the second orbit. If it is in the second orbit, that means also it is under the influence of nucleus. If I get it in the third, then also it is under the nucleus. Now, when will it become independent of the influence of nucleus? Only if it goes to infinity, right? But for infinity, we don't need infinite amount of energy. We need just that much of an amount of energy in which that particular electron is present. So, for example, we can write, see, E infinity for the ionization energy. Okay, ionization energy is equal to E infinity, that is the final state, minus E1. Okay, guys, E infinity minus E1, because we are sending from 1 to infinity. So from 1 to infinity, where is the formula? E2 minus E1. This is the formula, na? E2 minus E1. So we have E2 minus E1. Where did we go? Yeah, infinity minus 1. This is the final state. This is the initial state. This will be equal to what? Okay, now tell me, will there be any force of attraction between the nucleus and the electron if the electron is in infinity? ऐसे qualitatively सोच के देखिए आप कि nucleus and the distance between the nucleus and the electron is infinite. So will there be any force of attraction between the nucleus and the electron? Everyone is silent. I mean, you can speak something, na? If you have some logical answer, you think sir ऐसे हो सकता है, then I will ask you how it will happen. Yes, tell me. Hamza wants to speak something. He turned his mic on, then it is off. Somebody please. No one? Yes, Khalid.
Yes, sir.
I am asking, will there be any force of attraction between electron and nucleus if the electron is in infinity, if the electron is infinite distance away from the nucleus? Will the nucleus be able to attract it at that point?
No, sir, I think.
No, na? How many are with Khalid? Yes, Hamza, are you with Khalid or you have some different opinion?
No, sir, it will not attract.
It will not attract. Now see, you can also, what is the formula for energy? Energy for any orbital is it is equal to, I can write minus 13.6 into z square divided by n square. So for infinity, what I have to put? I have to put, rather than n square, what I have to do? I have to do infinity square. So anything divided by infinity, it will be equal to 0, na? Anything divided by infinity, it will be also equal to 0. This is 0 minus. What is the, what is the energy for the first level? It is equal to 13.6 z square divided by 1 square. Okay, this all will be in electron volts per atom. For one atom, we need this much amount of energy. So the ionization energy, it is equal to what? It is equal to 13.6. So this negative will cancel each other. 13.6 into z square electron volt per atom. I hope, Hamza, did you understand this?
Yes, sir.
Okay, Hiba.
Yes, sir.
Salman. Khalid.
Yes, sir, understood.
Understood. Okay, very good. What is this Z? Atomic number. If I ask you to calculate the ionization energy, always please remember this complete Bohr model is only for what? One electron system. It is only applicable for one electron system. That means the electrons should be in the which level? In the first level. That is why this 13.6 is only applicable if the electron is in the first level. For example, if I ask you about the ionization energy of carbon atom, so what we have to do? Carbon atom has 2 electrons here, 4 electrons in the next. If I remove this one of the electrons from the fourth shell, what will happen? We can again get what? The ionization energy, but that will not be equal to this number. We cannot calculate the ionization energy by here because we have put the orbital as 1. We have put the orbital as 1. Okay, fine. So what are the orbits that we can see? For hydrogen, we can calculate easily ionization energy. For helium also, because both of the electrons of helium is present in where? In the first orbit only. So both the energy of these electrons are same. Okay, please write this down. Complete this slide. Are you done?
Yes, sir.
Yes, sir.
Everyone?
Yes, sir.
Okay. So I will ask you, question is, calculate the ionization energy of helium plus atom in electron volt per atom. You just have to put the first formula. It's very easy, na? Ionization energy is equal to positive, okay, 13.6 into Z square electron volt per atom. What will be the answer? Yes, correct, Colin. Please don't forget Z. What is the Z here? Please don't forget Z. You forget Z, it is very shameful. You will do the question even if you know the answer. I mean, even if you are knowing the formula, still if you do a mistake, it is very sad, no? I'm waiting for answers from Hamza. Hiba first, please. Correct, Hamza. Waiting for Hiba. $54. Very good. Okay, fine. Now, since you have done some numericals here, let us write few remarks about Bohr model, and you will understand each and every point, because here I will be defining what is ground state, what is excited state. Okay, what will be the maximum energy of any electron. Remarks. Remarks is, the first point is that you will be thinking, sir, what is this point? It is just so ridiculous. The maximum energy of an electron is 0. Okay, is this making sense or it is not making sense now? The maximum energy of an electron is 0. How many of you agree? How many of you disagree? You agree?
Sir, minimum can be 0, but maximum 0.
0.
It can't be 0 maximum.
Maximum cannot be 0, na? Wait a second. Tell me, what is the energy of the first level? It is equal to minus 13.6 electron volt per atom. Okay, minus 13.6 electron volt per atom. Okay, and what will be the energy level of, sorry, what will be the energy of second level? It will be minus 13.6. What do we have? N square, na? Below we have what? N square. So if I add 2 here, this will be equal to 4 electron volt per atom. Okay. Now tell me, this is the first and this is the second. Which is higher? Is 1 or 2? Is 1 higher or 2 higher?
Sir, 1.
1 is higher or 2 is higher? I mean the whole
One.
number, including the negative sign.
Sir, 2.
2 is higher. Okay. Now that means I can say E1 is greater than E2. It is greater than E3. Greater than E4. Okay. So what will be the? So the see E1 is what? Having maximum energy, na?
Yes, sir.
अभी आपने कहा 2 is having maximum energy, more energy than E1 ना? Which is higher, 1 or 2?
Sir, 2.
So this will be the arrow na? Okay. So E1 is the smallest energy that is possible. Then E2, then E3, then E4. Can I write the maximum energy possible will be E infinity? Can I write this?
Yes, sir.
And what is the
Yes, sir.
energy when it is at infinity?
0.
0.
So it is a bit counterintuitive, right? The maximum energy is 0.
Yes, sir.
But always remember that negative sign is because what? That I mean the energy between them is 0, but there is a force of attraction between them, and that force of attraction, that attraction words gives the negative sign. That attraction words word gives the negative sign. If you have any positive energy, that will be leading to repulsion. Okay, and positive energy means it is unstable. You always want something. I mean, if there is any change, okay, now the whole change in energy kind of things I will teach you in. There are principles of chemistry, first principles of chemistry that will help you in deciding many things. But I will teach that in the second chapter. Oh, this is the second chapter. It will come at the end, but at the end, the maximum energy of an electron is 0. What does this mean? This means that electron is present infinite distance from nucleus. Okay, next point. Now when we have the total energy of any electron as negative, it means that there is attraction. Okay, so this is the next point that you can write. Total energy of an electron is negative. Okay, it means that electron is under influence of electron is under the influence of nucleus and being and in attraction and in attraction and in attraction. Okay, now there is one term which is known as ground state. Okay, ground state is the lowest energy state. Lowest energy state. What is the lowest energy state? The first, okay, write this. If electron is present, electron is present in first orbit. Okay, then it is called GS, not general state studies, it is ground state. Okay, GS is ground state. Then there is a term which is known as excited state. So excited state, we write this as ES. Okay, any energy level, energy level above the ground state is excited state. Okay, any energy level above the ground state is excited state. Okay, any energy level above ground state is excited state. It is what? It is excited state. Got it? I have a few questions. This is the nucleus. First, second, third, so the first energy level I can write this as GS, the ground state. The second energy level is known as ES1. That is the first excited state, right? This is ES1. What is the third shell? It is known as excited state 2, second excited state. Do you guys understand this nomenclature now? Ground state is what? 1. But if I say its first excited state, it is the shell number 2. Ground state is equal to shell number 1. First excited state, that is ES1, it is equal to shell number 2. If I write ES2, it is equal to shell number 3. Yes, Hamza, Heba, Salman, and Khalid, did you understand this?
Yes, sir.
Okay, fine.
Yes,
Completed,
sir.
completed the slide. Completed. Are you done?
Yes, sir.
Everyone?
Yes, sir.
Yes.
Everyone is done. Okay. Somebody is saying something. Salman is also done. Okay. Let us do a few more questions. Okay. Calculate the amount of energy required for the transition of energy required for the transition of the electron from third orbit to fourth orbit. Third orbit to fourth orbit. Okay. So see, I'm writing the solution. I'm starting it. Okay. But please tell me, can I first of all, what is the change in the energy? Delta E. Change is final minus initial. So what is the final orbit? Hiba, what is the final orbit in which the electron went?
Fourth.
Yes. So we'll write the energy of the fourth shell minus it. What was the initial, Hamza? What was the initial?
So third.
Third, E3. So in terms of electron volts, what will be the formula for E4? It will be equal to, okay, let us write for helium positive. Okay, for helium positive. So if helium positive is there, then I will write 13.6 into Z square. Rather than Z square, what will be the Z for helium? Hamza, the Z for helium?
So 2.
Very good. Okay. Why are you still hesitant? 2 square divided by, what is the N here?
And it is 1.
N is 1. Very good. What is the N here?
Oh, here it's 4.
Okay. So 4 square minus. You will write. Now, Khalid, tell me what should I write instead of E3 in this form? Yes, Khalid.
Yes, sir.
Yes, tell me what should I write here? 13.6?
13.6 into 1 point. No.
Z,
3
Z.
square.
Helium.
Oh, sorry. 2 square
2 square,
divided by 3 square.
3 square. See, I understand now. You are having some hesitance because you said, sir, ये E4 में कौन सा Z ले, sir, E3 में कौन सा Z ले? First of all, picture it. How will you picture it? This is the helium atom which has 2 protons. First shell, second shell, third shell, fourth shell. Okay, 1, 2, 3, and 4. So you have to transfer the electron from the third shell to the fourth shell, and it is asking the energy required for that. So as you picture it, what will be the Z? Always 2, because the proton number is 2. Now what will be the for 4 shell, the n will be what? 4 square. For 3 it will be 3 square. Okay, so first picture this thing also qualitatively, then quantitatively calculate the energy. That is the energy that will be required now. Calculate this. So you can take 13.6 into 4 square as common, right? Into 4. 13.6 into 4 will be common, and you will be remaining with 1 by 16 minus 1 by 9. Start calculating. Don't wait, huh? Start calculating. One by 16, and guys, you can easily calculate. See, 1 by 16 is what? 1 by 16 is 1 by 4 into 1 by 4. What is 1 by 4? It is equal to 0.25 into 0.25. 24 squares, most of the people remember, it is equal to 625. Now 625, this has how many decimal after 0.2, and this also has 2. So this answer will have 4. So 0.0625. So this is what? This is 54.4 from the previous answers divided minus 0.625. Sorry, 0.0625 minus what will be 1 by 9? 1 by 9, you can write it like this now. 1 by 9 is equal to 1 by 3 into 1 by 3. Correct? 1
Yes,
by
sir.
3 into 1 by 3. So you have 1 by 3. 1 by 3 is equal to how much? 0.33 into 0.33. This will be equal to how much?
1.1089.
1.10, 0.1089.
Sorry, 0 point. Oh,
Okay, so if you just see, if you add one more 3, this will again increase, na? If you add one more 3, it will increase. So it is approximately equal to 0.111. Okay, 0.11. So 0.0625, sorry, 0.11 is 0.11. Okay, there is one thing that yeah, I should write it here. See, this negative negative will become positive, but this will be negative. We forgot the negative signs here. So this 0.616 will be negative. This will be also negative. So this will become positive and this will become negative. Now calculate the answer. We forgot the sign. Somebody gave me answer. It will not be in minus. It will not be in negative, Khalid, na? It won't be in negative. Now it will be in positive, na? If you look at the sign.
okay, sir.
So first you will get 54.4 into This is minus 0.625 subtracted from 0.11. This will give you 0.0475. This will be equal to how much? 2.584 electron volts per atom. Okay. So can you guys do this type of questions now? Can you guys do this type of questions now?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Now, okay, let us see. Okay. Question is calculate the ionization energy Oh wait, not ionization. If I say ionization energy, it will be in the first. Calculate the amount of energy. Calculate the amount of energy required to remove an electron of the electron, because one electron system for Bohr model, from helium positive if electron is in fifth orbit. Okay, if it is in the fifth orbit. Okay, now this is what helium, and it is in the fifth orbit. So Hiba will tell me, can I use this formula? Because we are removing an electron, can I use this formula? Yes, Hiba. The formula that I have boxed in red. Yes.
Yes,
How
sir.
many? Yes, we can use this formula, right?
Yes, sir.
Okay. आप लोग का ध्यान कहाँ रहता है? See, the ionization energy has, what is the n here? What is the n here, Hiba?
1.
1. What is the n here?
5.
5, na? So see, this question is not regarding ionization energy. The amount of energy required to remove the electron from the helium positive if the electron is in the fifth orbit. So what we are doing is, if it is in the fifth orbit, this is the fifth orbit, this is the electron. So we are removing the electron. We are not shifting it to the sixth. We are not shifting it to the sixth. This is not happening. We are removing. When we remove a particular electron from the orbit, what we are doing, we are removing it and we are putting it at the energy which is level infinity. So the energy required will be equal to E infinity, because that is the final. What is the initial? Where is the electron, in which orbit?
5.
Yes,
Fifth.
fifth orbit. Okay. So you'll calculate it in this way. E infinity is equal to 0 minus, then you will add minus 13.6 divided by 5 square, because n square into z square. Z will be here equal to 2 square because it is helium. Now you will calculate the answer. Okay. Calculate this fast and tell me what is the answer. You will get answer somewhere 2 point something you will get, I guess. Calculate and tell me, na, 2 point something. Correct, correct. Hamza is right. Khalid is also right. Waiting for Hiba. Salman is also right. We'll get it something like this. Okay, what is? Wait a second. Wait a second. Okay, fine. Khalid is not right. Hamza, Hamza is also not right, I guess. See the sign. See the sign. Okay, see the sign. Just wait a second. See the sign and check the answer. अच्छा, I'm really sorry. मेरे उस्ताद का कॉल आ गया था. Okay, fine. See here. So I just picked up and told that I will call in 5 minutes. Okay. So this will be positive, right? Whatever energy you will getting, it will be positive. Negative, negative is positive. So this will be 13.6 divided by 25 into 4 square. So sorry, not 4 square, rather it is 4. So what I knew was 13.6 into 4, it is equal to 54.4 divided by 25. So this will be approximately 2.2 or 2.18 also is right. Okay, electron volt per atom. Yes. Did you correct the mistake? Hamza, Hamza, did you write that answer? I mean, I cannot. Okay, wait a second. Salman is writing what Salman did. I mean, I cannot scroll. The mouse pad is not very good. Okay. Now I want to tell you a very interesting thing that we will learn in the next class. Okay. This is about de Broglie hypothesis, and you will love this thing, and I will explain it to you. Okay. Have you learned about? I mean, this equation. You know this equation? Is equal to mc square.
Yes, sir. I guess energy for energy.
For energy, it is there. Na? E is equal to mc square. Einstein's favorite.
Yes, sir.
Not favorite. It is by Einstein. Okay.
This is
And
very
there is
famous. By
very famous, very famous. Okay. It is in the popular culture also. You've also seen electron. I mean, energy is equal to hc divided by lambda. Correct.
Yes, sir.
Okay. Now, de Broglie was such a chatur thing. He was. What did he do? He equated these two things. That m c square is equal to hc upon lambda. Hc upon lambda. Now we can say that this will be equal to mc is equal to, can I say that mc will be equal to h upon lambda. So he said that okay fine, then wavelength will be equal to h upon m into c. This is for what? This is for electromagnetic waves. So now can you see that he associated wave with mass? That is the dual property, or let's say, yeah, dual nature of light. What did he associated? He associated the wavelength with masses. For wavelength is the property of wave. Mass is the property of particle. Now, please listen. Now, please listen. He further extended this and said that we can also write lambda is equal to h upon m into velocity. Now, this will be applicable for anything. For anything which has mass, it will have some wavelength. Now, tell me, do you guys have your mass? You have mass or no? You don't have any
Yes,
mass.
sir.
You have mass. That means you will be also having some wavelength. Now, if you are okay to disclose your mass, then we will be calculating our wavelengths. Okay, if you are traveling at a particular speed. Now, how many of you know how to drive a car or bike?
The car.
Car. Okay, fine. So Hamza knows. What about Khalid? No. Khalid, do you know how to drive car? Khalid is not answering. I
No,
guess
but never driven one.
never driven. Okay, fine.
Yeah, I
So
did.
Hamza, see, I mean, okay, this is something. Hiba is also present ना, so Hiba can वो तो आपके अब्बू को बता देगी, ठीक है? क्योंकि I would have asked what is the fastest speed that you have went. Can you say what is the fastest speed that you have went? या हिबा बता देगी घर पे?
No, sir. I haven't driven my father's car yet.
You have not driven,
No, sir.
but you know how to drive.
Yes, sir.
ये
Like
कैसे होगा भाई?
sir, I went with my friend, so I have driven there.
So if you have, okay, not your father's car, but you have driven somewhere now.
Yes, sir.
If you have driven somewhere, then can you disclose the fastest speed?
60 maybe.
60. Okay, fine. 60 is okay then. Then in the next class, now what we will do, we'll calculate what would be your wavelength if you are traveling at 60 kilometers per hour. Okay, because see from this equation, see Planck's constant is a constant. The mass, I mean, you can disclose what is your mass. The velocity we know. Then we will calculate the lambdas. Okay, fine.
Yes, sir.
Okay. I can give this you as homework also, na? This is write this as homework. Okay, so for mass, everyone will take their own mass. Okay, calculate lambda for yourself if you are traveling at 60 kilometers per hour. Now a few things, please. First of all, convert this into meters per second. Convert this into meters per second. Okay, then only calculate your lambda. Okay, fun. In the next class, you have 1 week, Saturday, na? Yeah, we have class on Saturday. So in 1 week, you will let me know the answer. Okay, will everyone remember? Have you written this?
Yes, sir.
Have you written this?
Yes,
He
sir.
got Nobel Prize for this. Just, I mean, equating two equations, he got the Nobel Prize. De Broglie. Amazing, na? Actually, I mean, this is for it for today.
Can you
This
put
question.
the previous slide?
Previous slide, you don't have to write the previous slide. I have not, de Broglie hypothesis, I have not given you any notes here, na? You can see, but don't write.
Oh,
Okay, don't write. It is just like the
okay,
previous
sir.
class. I gave you trailer for Bohr model. Okay, see now you know that there, if anything has mass, it will have the wavelength. So I will just write down the points of de Broglie